just try to contain my excitement for tying together all the properties that we have now learned, and that is the purpose of this video and the next one after this. We are going to use multiple exponent properties together to simplify some really cool expressions. Let's dive into it. So in this one, we've got a product of 1, 2, 3 different expressions. So what do? Well, we use our product rules, right, with exponents, which says that if we have the same base, we add the exponents. I also multiply my numbers first. So mentally what I'm doing is I'm going to do 5 times negative 3 times 2. I'm rearranging everything because multiplication is commutative. And then I'm going to multiply the like variables. That'll be x to the third times x here and here. And then I've got the r to the negative 2. And that checks off all the components. So I've just rearranged the order in which they're being multiplied. 5 times negative 3 is negative 15, times 2 is negative 30. X cubed times x, which is x to the first, we add exponents when we multiply by the same base, so that's 3 plus 1 is 4, so that's x to the fourth. Then you have r to the negative 2. Well, a negative exponent means that that needs to end up in the denominator, so it ends up all over r squared, or 1 over r squared multiplied by that. And then we're done with it. One important note here is, when you're multiplying these coefficients, numbers multiplied by variables, don't add them, right? We add exponents when the bases are the same. We are multiplying these. Follow the operation as it's being told to you. All right, let's look at B. B, we've got a slightly less involved product, but the order of operations is important here. The order of operations says do parentheses, then exponents. Well, the parentheses, there's nothing to simplify, but we do the exponent first, r cubed to the negative 7th, before we multiply by r to the 6th. So we're going to get r to the 6th times r to the third to the negative 7, we multiply when we raise a power to a power. 3 times negative 7 is negative 21. And now from here, you have the same bases being multiplied. So the result, we add powers. 6 plus negative 21 is negative 15. So that's r to the negative 15. And of course, we now have a negative exponent. So it ends up being 1 over r to the 15th. The moral of the story here, peeps, take it a step at a time, applying one property at a time, always following the order of operations. Letter C. Well, we've got nothing that we can simplify inside the parentheses, but I'm raising it all to a negative power. So right away what I'm going to do is I'm going to apply that negative power, and that's 1 over 4z to the 5th, all of that raised to the second power. Now everything's being raised to the second power, so we distribute the power to each exponent there. So that's going to be 1 over 4 squared times z to the 2 times 5 is what I'm doing, which is z to the 10th. And now I'm left with 4 squared in the denominator. 4 times 4 is 16, so I get 1 over 16 z to the 10th. That's a beautiful thing. Nice. Piece by piece, step by step, keeping your mind about you because they can be a little overwhelming, these problems. Here, we can do a little bit of simplifying to start inside the parentheses if you like. We could put the x below, or we could just distribute the 4. So I'm going to go ahead and put the x below, and so that's going to be 2y to the 4th all over x to the 1st raised to the 4th power. So now that the inside is simplified, I'm going to raise everything to the 4th power, so that ends up being 2 to the 4th, remember distributing. Y to the 4th to the 4th, I'm multiplying 4 times 4 is y to the 16th, because you're raising a power to a power, so you multiply. And then that's going to be x to the 4th, because this is just x to the 1, and 1 times 4 is 4. We have a little bit left to simplify, just that 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2, 16. You're left with 16y to the 16th all over x to the 4th power. Nice. All right, m to the negative 1 n squared all over m to the 3rd n. Looks like we're using some division rules. So I noticed that the same base is here, so I'm going to do subtraction. Negative 1 minus 3 is m to the negative 4th. I'm subtracting the exponents of like bases. This is n to the 1st, n squared, 2 minus 1 is 1. So n to the 1, which is just n. And now the m is going to go into the denominator. So I have n over m to the 4th due to that negative exponent. I'd like you to eventually get to the point where you can go straight here, where you can say negative 1 minus 3 is negative 4. So I'm going to end up in the denominator with 4 m's. I think that'll make life a little easier for you. Last but certainly not least, I put one of these on here so that you remember that we don't subtract those numbers. We subtract exponents. But 6 and 3 are being divided, right? We don't subtract them to get 3. It is 6 divided by 3, which is 2. So it's going to be 2 over 1, right? 3 goes into 6 twice and into itself once, hence 2 over 1. C to the negative 1 over c to the 2. Negative 1 minus 2 is negative 3. We will subtract exponents because the bases are the same and we're dividing. So it's c to the negative 3. D to the 4th over d to the minus 3. Same basis, so we will subtract exponents. That'll be 4 minus a negative 3, which is d to the 7th. And now we'll simplify a little further. You get 2. Then you have c to the negative 3rd. That ends up in the denominator because it's got a negative exponent. And finally, d to the 7th is just hanging out up top. So the moral again, go piece by piece so you don't get too overwhelmed, and practice really being patient as you go through them and seeing one rule being applied at a time. In a later video, we'll go over some other problems that tie it all together, stepping it up a notch.